In this video, we will practice dividing rational expressions such as these. The main thing to remember about dividing with fractions is that you multiply by the reciprocal. So I'm going to wind up turning this into multiplication, and I'm going to wind up turning this fraction upside down. But first, we have a bunch of factoring that we need to do, starting with any common factor. All right, the first step of factoring is GCF, greatest common factor. So I see 3 of these expressions have a common factor. So starting with this numerator, all of these are divisible by 2. So before I even begin, I would just pull this 2 out of the trinomial. So if I divide everything by 2, that's going to give me 5b squared plus 21b plus 18. Similarly, if I pull the 2 out of this trinomial, then I've got 3b squared minus b minus 30. This has a common factor of 8. All right, that's the greatest common factor. So if I divide everything by 8, that's going to be 5b plus 6. This does not have a common factor, so I'm going to leave it alone. So now I'm going to go ahead and rewrite the problem while moving the process forward. So I am going to multiply by the reciprocal. So this division is becoming multiplication. And when I write this down, I'm going to write it upside down. So the 8 times 5b plus 6 will end up in the denominator, and my 3b squared minus 13b plus 10 will end up in the numerator. However, I'm going to factor as I do this as well. So I've got the 2, so that's great. All right, I'm going to keep that there. But the rest of this trinomial is going to factor as a binomial times a binomial. 5b squared can only factor as 5b times b. Now I'm looking at this 18. There are a number of ways to make 18. The first thing that pops into my mind is 3 times 6. Okay, so imagine this was 3 and imagine this was 6. Now inner plus outer must equal middle. Better highlight this to keep my eye on it. All right, this is the middle. This is our target is 21b. Okay, inner plus outer must equal 21b. Inner, I have 3b. And outer, right now, I have 30b. That is not going to make 21, no matter how I pick the signs. So I'm going to try switching those around. All right, I'll try putting the 6 here and the 3 here. 6 times 3 makes 18. Inner, I have 6b. Outer, I have 15b. 15 plus 6 is 21. So if I just leave these both positive, that will make 21b. And positive times a positive is a positive. So this is working for me. Okay, let's see, can I get rid of this yellow without erasing the whole problem? Sort of, kind of, because now I want to highlight this negative b. Because I'm going to factor this, and now this is my target. Okay, so I have the 2, and again, I'm going to try to factor this trinomial as a binomial times a binomial. 3b squared can only be 3b times b. Now 30 could be 2 times 15 or 3 times 10. Okay, I'm going to try 10 times 3. By the way, I knew not to put the 3 here. I would not waste my time with this version, 3 and 10, because you should never have a common factor inside the parentheses. if you pulled out the common factor in the first place like we did, like you should always do, there should never be a common factor still inside your parentheses. So 3 and 3 would be a common factor, so I know that that's not going to be the answer. So I will save time by going straight to 10 and 3 instead. Now, inner plus outer must equal middle. Inner, I have 10b. Outer, I have 9b. I'm trying to get -1. So if I have a -10 and a +9, that'll make the -1 that I want. So there's my -10, and this will make the +9. Also, a negative times a positive is a -30. So this is working. So now we have factored all of this out. The only thing we haven't factored is this trinomial. So I'm actually going to go ahead and erase that, and I'm going to go back and factor it now. Okay, so I'm factoring this. So 3b squared will only factor as 3b times b. 10 is either going to be 2 times 5 or 1 times 10. All right, I will try 2 times 5. Inner plus outer equals middle. Inner, I have 2b. Outer, I have 15b. That can make -13 if I have a +2 and a -15. That will make 13. However, there's a problem. So I have 2 and I have 15. However, there's a problem. That means this would have to be positive and this would have to be negative. But a positive times a negative would make a -10, not a +10. So that was really close, but sadly, no. That is a fail. Okay, so that did not work out with the 2 times 5. I will try 5 and 2 in case that makes a difference. Inner, I have 5b. Outer, I have 6b. That makes 11, not 13, so that's no good. So the 5 times 2 option is not working. So I'm going to try the 1 times 10. All right, and I'm going to go ahead and try putting the 10 here and the 1 here because I'm kind of looking ahead, and I think I see what's going to happen. Inner, I have 10b. Outer, I have 3b. I'm trying to get the middle of -13. If both of these are negative, that makes -13. So that means both of these would be negative, and a negative times a negative is a positive for the +10. So this is working. Okay, now we have factored everything. Now it's time to cancel out anything that is in the numerator and the denominator, any factor. All right, and I'm going to cancel by highlighting so you can still see through it. For example, here I see 5b plus 6 in the numerator and 5b plus 6 in the denominator. Those will cancel out, so those will be gone. I also see b plus 3 in the numerator and the denominator. So I see b plus 3 and another b plus 3. So those will cancel out. They have to be one high and one low. They don't have to be in the same fraction. Okay, what's next? I see 3b minus 10 in the numerator and 3b minus 10 in the denominator. So those cancel out. And I also see 2 in the numerator and the denominator, a factor of 2. So those will cancel out. So the only thing I actually have left is in the numerator I have b minus 1, and in the denominator I have 8. So that is the simplified version. Now, we need to talk about excluded values. All right, we need to write those down. Okay, so the restricted values are going to come from this denominator and this denominator, and it's also going to come from here, all right, because we're going to wind up turning this upside down, And now this 4b plus 48, that's where this came from, which is now in the denominator. So when you're doing a division problem, you're going to look in these three places for your excluded values. Look in both denominators, of course. None of these can be equal to 0. But also this second numerator, none of these can equal 0 either. All right, so I'm just going to set each of these equal to 0 one at a time. The constant doesn't matter. If I were to set 3b minus 10 equal to 0, that would give me b cannot equal 10 over 3. If I were to set b plus 3 equal to 0, that would give me b cannot equal negative 3. Okay, now if I set 5b plus 6 equal to 0, that would tell me that b cannot equal negative 6 over 5. Let me just show one of these. I'm just saying it, and I'm assuming you know what I'm talking about, but I'll show my work one time. I'm saying if I set 5b plus 6 equal to 0 and solve, so I would wind up subtracting 6, so that would be 5b is equal to negative 6, and then I would divide by 5, and that would give me b is equal to negative 6/5. So that means b cannot equal negative 6/5. So that's what I mean when I say if we set this equal to 0. All right, but there's one more. Actually, there's one more. So we need to look at the numerator here as well, because it used to be the denominator. If I set these equal to 0, if I set 3b minus 10 equal to 0, I already have that from before, so that would again be 10 over 3. But if I set b minus 1 equal to 0, that's going to tell me that b cannot equal positive 1. Okay, so these are my restrictions, my excluded values. Okay, so I'm just going to look for this answer among my multiple choice options. Okay, so I'm looking here, and I see I need b minus 1 over 8. So that's D. And if you look at all the excluded values, they also match. So the answer is D.